Welcome to MRL. In this learning session, we'll be learning about a very important branch of mathematics, that is algebra. Now, algebra is a branch of mathematics that generalizes mathematical concepts. Letters are used to represent numbers, values, and variables. General rules or formulae are established for solving different problems in mathematics, and of course easily. Operations and properties of numbers are applicable. We have got different fundamental operations, so also it is applicable for in algebra, and the properties of numbers are applicable as letters in algebra represent numbers. Now, a constant. A constant is a quantity which has a fixed value. Numerals are constants. Some variables are also taken as constants. Now 3 is a constant because it has a fixed value. So also -2 is a constant, and because it has a fixed value. A variable is a quantity which does not have a fixed value. A variable is denoted by letters x, y, z, etc. Variables are also called literals or literal numbers. Algebraic term. An algebraic term is a number, a variable, or a product, or a quotient of a constant and a variable of any power and sign. Now, if you consider these examples here, x is a variable, but x is also an algebraic term. Minus x is an algebraic term. Minus 5x is the product of minus 5 and x. It is an algebraic term. X by 2 is a quotient. X divided by 2 is a quotient, and that also is an algebraic term. And the algebraic variables can be with any power. Even x square is an algebraic term with power 2. So like that, that is how we define algebraic terms. Factors of an algebraic term. In the term minus 5xy square, the factors are minus 5, x, y, and y. That means I can split minus 5xy square as minus 5 is one coefficient, x is another coefficient or factor, and y square is another what you call factor, and y square can be split as y and y. So this is the tree diagram of factors. So please remember that. Now when I multiply the factors, I get back the algebraic term. Now, like algebraic terms, rather it's very simple. We already know what is a factor. A factor is that which divides a given algebraic expression completely, as we have learnt in mathematics. Like algebraic terms, the algebraic terms having same variable with same power or exponent are called as like terms. Let us understand this. Now, if you look at 3x and minus 5x, variable is same, power of x is 1, power of x is 1 here also, and therefore they are like algebraic terms. Please remember, it is the sign and the numerical coefficients are neglected, are not taken in describing or deciding like algebraic term. Now take this example: 2xy square, 7xy square. 2 and 7, they are numerical coefficients, leave them. X and x is a variable with power 1. Y square is another variable with power 2. Therefore 2xy square and 7xy square are what we call like algebraic terms. Therefore remember, the algebraic terms having same variable and same power or exponent of the variables is what are called as like algebraic terms. Now unlike algebraic terms, the algebraic terms having different variables with different powers, and both different variables and powers are called unlike algebraic terms. Now if you look here, x and y are different variables. X square have the same variables but the powers are different, and therefore they are unlike. X, y square are here, both the variables are different and also the powers are different, therefore they are unlike algebraic terms. Now let us take about coefficient. A factor or product of factors of a term is coefficient of the remaining factor. If the coefficient is only a number, then it is called as numerical coefficient. If the coefficient is only a variable, then it is a literal coefficient. The coefficient can also be a product of a number and literal or a variable. For example, if you take the example 6 BCD here, coefficient of BCD is 6. Coefficient of 6 CD is B, and coefficient of D is 6 BC. So please remember, so we have different types of coefficient. There is numerical coefficient and literal coefficient. Now algebraic expression. Algebraic term or sum of algebraic terms is an algebraic expression. Now if you look here, 3m is an algebraic term, 2 is also an algebraic term. I have added 3m with 2, and 3m and 2 are added here with a plus sign, and this becomes an algebraic expression. Here also we have three algebraic terms, and we have taken an algebraic sum of all these three terms. That becomes an algebraic expression. This is also an algebraic expression, that is minus 7x square. So therefore algebraic term or sum of algebraic terms is an algebraic expression. Now a polynomial, an algebraic expression with powers of variables as whole numbers or positive integers, is a polynomial. Now if you look at this example here, 3x square plus 2x plus 5 is a polynomial because there is a variable x with the power 2 and x with the power 1, then the powers are positive integers, therefore this is a polynomial. Please remember this. That means an algebraic expression becomes a polynomial or is a polynomial if the powers of the variables are positive integers or whole numbers. On the basis of number of terms, we have different types of polynomials. We have a monomial with one algebraic expression, and we have one algebraic term, that is a polynomial of one term is a monomial. Binomial is an algebraic expression with two terms, and a polynomial of two terms is a binomial. So x plus 7 x square plus y square is a binomial. A polynomial of three terms is a trinomial. Here x plus 5 plus 4 are three terms, three algebraic terms, therefore it is a trinomial. So also x square plus 2x plus 7 is an algebraic expression with three terms, and therefore it is called as trinomial. Now an algebraic expression of any number of terms is called as a multinomial. A polynomial is a multinomial. A multinomial is not always a polynomial. Please remember that. Now framing algebraic expression from a statement. Now here we are given a statement, we have to frame algebraic expression. Twice the quantity of x. Twice the quantity of x is 2x. E is increased means added by 4. So twice the quantity of x is increased by 4. Therefore the algebraic expression of this statement is 2x plus 4. So to read the statement correctly, understand and then frame the algebraic expression. Add 1 to k. Add 1 to k, that means k plus 1. And divide 4 times the result. We have k plus 1 here, 4 times k plus 1 by the result by 7. So the statement is to be understood, and this is the algebraic expression of this statement. So we have to learn how to frame algebraic expressions from given statements. These are very useful in calculations. Now if you are given an algebraic expression, then how to write a statement. This is writing a statement of an algebraic expression. Now here 2 in the bracket m plus 4 plus 5 is the algebraic expression. The statement would be twice 4 more than m. See here, m plus 4 is 4 more than m, and twice that is added to 5. So twice 4 more than m is added to 5 is the statement of this algebraic expression. So we have to know how to write an algebraic expression of a statement, or writing an algebraic expression into a statement. Now operations on algebraic expressions. When we say operations, it is addition, subtraction, multiplication and division. So let us understand the addition and subtraction of algebraic expressions. Now there are certain rules. Remember, only like terms can be added or subtracted. Rules of integers is followed. Please understand, rules of integers is followed, sign rules of integers is followed, and properties of numbers is also applicable. So these are the basic rules which you have to remember for addition and subtraction of algebraic expressions. Now let us go for the methods of addition and subtraction. We have got two methods, that is the vertical method and the horizontal method. So let us learn them with examples. Now let us say we have an example here. Add 2x plus 6y and 3x minus 2y. If I have to go for vertical method, then write 2x plus 6y and write 3x minus 2y below that. Add it. Add the terms as we add the numbers. Add 6y minus 2y. They are like terms. Plus 6 is greater, minus 2 is smaller. So plus 6 minus 2 becomes 4y. See, again I have taken the coefficient. Numerical coefficients are there. So follow the rules of integers. So plus 6 minus 2. Plus 6 is greater, minus 2 is smaller. So that means plus 6 minus 2 becomes 4y. So therefore we have the 4y is the difference here. Now here 2x plus 3x, that means 2 plus 3 is 5x. So therefore the sum of these two algebraic expressions is 5x plus 4y. This is the vertical method. In the horizontal method, just write 2x plus 6y in the bracket with the addition sign and 3x minus 2y in the another bracket. Now open the bracket. Please be careful. 2x plus 6y as it is, plus into plus is plus 3x, plus into minus is minus 2y. So always when we open the bracket, we have to multiply the signs first and then open the bracket. Now 2x plus 3x, bring the like terms together. 2x plus 3x are like, therefore they are brought together, and 6y minus 2y are together because they are like terms. Then 2x plus 3x means 2 plus 3, that is 5x. 6 minus 2 is 4y, and that is again 5x plus 4y. So we can go for a vertical method or horizontal method for addition and subtraction of algebraic expression.